Okay, so 7-2, similarity transformations. So it says, Helena and Edwin are asked to apply a composition of transformations to A, B, C, D. So here's A, B, C, D. Use appropriate tools. Is there a composition of transformations that maps A, B, C, D to the second figure in each student's work? If so, what is it? So in this case, if we look at A, B, C, D for, let's say, Helena, okay? The thing you want to identify here first is what sides go with what sides, or what vertices are what vertices, okay? So if I look at this, I have this smaller one, which is a length of 2, and this guy is straight with XY, all right? So my guess would be is that we're going to need some type of enlargement and then probably a reflection of some kind, right? But let's double check that. So in this case, I look at C. Looks like, yeah, C is probably lining up with X. Oops, maybe actually, better yet, it'd probably be better if it was a rotation. So that B lines up with X, C lines up with Y, and then everything should work out. So that's what I'm going to write down. So for Helena, it's going to use a capital H on her. We're going to rotate A, B, C, D. Looks like 180 degrees, okay? Then dilate it. There we go. With a scale factor of 2. Okay. Now, if I wanted to write the function for this, remember we kind of go from right to left. So the thing on the right is what we do first. We're talking about a rotation, 180 degrees, let's say about the origin. And then we're going to have after that a dilation with a scale factor of 2 for A, B, C, D. Okay. Now for Edwin, here's Edwin's. All right. So here again, here's our original shape. Nothing changed there. And here's what he has. So it looks like do these look like the same shape? Like, is ABCD look kind of the same as JHGF? I don't know. This H looks a little different, doesn't it? Like it's kind of like an extra, like it's a point, like it's kind of pulled a little bit, right? Because this is not look like the original shape really at all. There is no composition of transformations. So remember from yesterday where the shape might get bigger or smaller, but it still retains its overall idea of the shape, right? It's not going to do anything different or special with just one of the vertices or just one of the sides. All right, so let's talk about what a similarity transformation is. A similarity transformation is a composition of one or more rigid motions and a dilation. Remind me, oh my God, why do I keep doing that? I can never spell this. There we go. And a dilation. Is a dilation a rigid motion? Who remembers from yesterday? What do you guys think? Now remember, the definition of rigid motion is that angles and side lengths are all preserved. Does a dilation represent a rigid motion? Angles are preserved. Are side lengths? No. So is a dilation a rigid motion? No, it's not. Okay. All right. So the second part of this is that a similarity transformation results in an image that is similar to the pre-image. It's not saying it's going to be exact. It's saying it's going to be similar. It can't be exact because we have that dilation in there, because that's not a rigid motion. But it should have some type of ratio, and that's where the scale factors come in. That scale factor is kind of like that ratio of how it's enlarging or reducing. Question on this? Anybody still writing? All right, example 1. It says consider ABC with vertices 2, 4, -2, 8, and C, 0, 10. What are the coordinates of the image after a triangle ABC, a dilation of half about the origin, and then a reflection across x equals 3? All right, so let's take a look down here. We have our original points. We have 2, 4, we have 2, 8, we have 1, 10. Now, they're telling us to do the dilation first. So the dilation, remember, we're going to multiply everything by 1/2. We did that yesterday. That's our scale factor, is 1/2. So this will be 2 times 1/2, which leaves us with 1. And then we're going to have 4 times 1/2, which leaves us with 2. We're going to do -2 times 1/2, which leaves us with -1. And we're going to have 8 times 2, which leaves us with 4. And then we're going to have 0 divided by half. Well, that's still 0. And then 10 times 1/2 leaves us with 10. So these are our new points for the intermediate image. This is after we dilate it by a scale factor of 1/2. Now, you guys remember your foldables from reflections? I think it was topic 3. If you got them, take them out, because those rules still apply. Remember when I said don't get rid of those? You're going to see them again second semester. Welcome to second semester. All right, so if you have them, take them out. If you don't have it, find it. Okay? If you got rid of it, let me know. I can print out more. Okay? You got rid of it, Luis? Okay. Anybody else? Can't do that in this class. So someone tell me, they're talking about a rotation or a reflection across x equals -3. Now, is there an actual rule for x equals -3 on your foldable? Yes or no? I don't think so, right? It's got x-axis, I think it's got y-axis, and it has y equals x and -x, right? All right, so this doesn't have an actual rule, so this is one we're going to have to plot and then kind of look at it and make it equidistant, right? So the first thing I'm going to do is, looking at this top picture, I'm physically going to plot these 3 points, okay? So I have 1, 2. That's the A prime. B prime is -1 up to 4. And then C prime is 0 up to 5. So here is my plotted image, and they're telling us to reflect across the line x equals -3. So here is my line. And from there, I'm going to make everything equidistant. So B prime is over 2. There's B prime, or I should say B double prime. A is 1, 2, 3, 4. So 1, 2, 3, 4, landing right there. And C is going 1, 2, 3. So 1, 2, 3. Kind of landed with my D. So there's C double prime. So these are the points. So it looks like A is -7. Well, let's see, -7 up to 2. B ends up being -5 up to 4. And C ends up being -6, 5. So that's what you're going to write down under the final image. A, -7, 2. B, -5, 4. And C, -6, 5. Okay? Does that make sense? Now, if it gave us something like the x-axis, you can just apply the rule. You don't even have to graph it. Okay? Just kind of keep going with the motion of everything. And you can just get the table and be done. But if it's not like that and you do need to visualize it, graphing it is always the best way. Okay? Questions on that? All right, let's take a look at the backside. Anybody still writing before I move on? All right, concept summary. It says in words, a similarity transformation is a composition of one or more rigid motions and a dilation. Two figures are similar if there is a similarity transformation that maps one onto the other. So we're still trying to get one to the other, like we did last time, okay? All circles are similar to each other. It does not matter. You can shift them, you can do whatever you want, but it doesn't matter. If it's a circle, it's similar automatically, okay? So looking at these diagrams, here we have X, Y, Z. If we look, it got, in this case, enlarged or dilated by some scale factor and then rotated. So in this case, if you look, this statement, this is the big statement right here, is that triangle ABC is similar to XYZ or vice versa. Okay? In this case, they're saying circle P is similar to circle Q. So this squiggly line means similar. Okay? No equal sign. We're not dealing with congruency. Just the squiggly. So let's take a look at this first. Try it. It says, is there a composition of transformations that maps triangle XYZ to triangle JKL? So here is our pre-image. Whoops. Here is our image. Now they look pretty similar. So if we look at this, we see that, is there a similarity between these two? Yes or no? What do you guys think? Yeah, definitely. Now, I'm not looking for exact, I'm looking for an idea. If it's going from here to here, what is happening? It's being what? Is it being rotated? Is it being reflected? Is it being translated? What do you guys think? What's happening here? Not looking for exact points, so I'm not worried about that. Just give me an idea. Well, let's see. Does this look like a reflection? No. Okay. Does it look like a translation? No, I don't think so. Does it look like a rotation? I'd say so. Goes from here. There's K. So this was definitely triangle XYZ was rotated, okay, and then from there it was dilated. Questions on that? All right, number 2. Now this is what I said. You remember, if you can just go with it, then write down the points, and then you can plot them later if you need to. All right. Consider triangle ABC with vertices A, -6, 4, B, 3, 5, and C, 2, 1. Perform a composition of 2 transformations. A translation of T, 3, -3, then a dilation of 1/2 about the origin. All right, so what I'm going to look at here is I'm first going to identify these points. So A is right here. A is -5, 4. B is 3, 5. And C is 2, 1. So that's what I'm going to write down here. All right, so the first thing they want us to do is do the translation of 3, -3. So remember, this means we're adding 3 to X and subtracting 3 from Y. I think this is the one. Okay. So adding 3 that leaves us with -2, 1. This will be A double prime. B double prime is going to be 6, 2. And C double prime is going to be, looks like 5, -2. Okay. So that takes care of the translation. Oh, I should have. Sorry. Oops. No, don't clear the screen. Let's see, triple prime. Okay. Yeah, I accidentally put a double prime here, guys, but just go triple prime. It'll be fine. It'll all work out the same. All right, so now it says they want a dilation of 1/2 about the origin. So you're going to multiply everything by 1/2 now. So -2 times 1/2 leaves you with -1. And 1 times 1/2 just leaves you with 1/2. For B, 6 times 1/2 leaves you with 3. 2 times 1/2 leaves you with 1. And then C is going to be 5 times 1/2, which leaves you with 5/2 or 2.5, whichever you want. And -2 1/2 leaves you with -1. So there are your points. Now, on your homework, you are going to be required to graph these. All right? We're going to see everything. If you want to do that now, I'm going to give you a couple minutes. Okay? When you're done, you can start working on number 3. Why don't you try number 3 on your own, but plot these points and then try number 3. Go ahead. I'll give you guys like 6 minutes.
Smith, can I charge my phone?
Sure.
Can this I charge?
Yeah, sure. Hey guys, someone brought it to my attention that this is at A is actually 6-4. Oops. So this should be -6. A should be, so this should be -3 instead, and this should be -3/2. Everything else looks good though. I figured going as well as myself, I have two such an important properties that you really need to find each of these points, right? Multiply x and y by 2 and then multiply. So it should get bigger, but look similar to how that's supposed to look. So like we look at f, that's -1, 0, right? And they want you to divide it by scale factor 2. They're saying 2 times 10 to the 4, which is 2, and 2 times 4, which is 0. So you plot f right there. And then you do the same for E and C for D. you see what I mean? This erases two other eights on this here. It's just a that.
Okay.
You see this is
Yeah, I didn't do that.
-1 times 2, and this is 0 times 2. And then you're going to do that A, B, C, and D. The primes? No, I just did that to say this is the first point, that's the second point. This is the point you're given, this is the point you're finding. Does that make sense? I want you to do this. Find each point, okay? And then multiply everything by 2. And then come back to it, okay? All right. Let's take a look at this. All right, so if you guys take a look here, they're telling us that we have 3, 1, 5, 3, and 1, 4 for these points. So that is what I am going to write in here. G is 3, 1, H is 5, 3, and S is 1, 4. Now they're saying that they want a dilation of 2, which means everything gets multiplied by 2. And then they want a rotation about the x-axis. Someone tell me, what is the rule for the x-axis according to your foldable? What's the rule for the x-axis? It goes from x, y to what? It goes from x, y to what? Come on, guys. Yeah. X negative y, right? All right, so let's multiply by 2. G prime, H prime, S prime. All right, so G is going to be 6, 2. H is going to be 10, 6. And S is going to be 2, 8. So there's our primes. And then I would plot these, right? So we're going to have 6, 2. So 1, 2, 3, 4, 5, 6. 1, 2. There's G. 7, 8, 9, 10. And then up 1, 2, 3, 4, 5, 6. There's H. And then S. 1, 2. And then 1, 2, 3, 4, 5, 6, 7, 8. So there's S prime. Okay, so there's that graph. Right there. All right, now the next part is that reflection. So this is going to be for G double prime, we're just going to make the y negative. So this will be 6, -2. H double prime is going to be 10, -6. And S double prime will be 2, -8. And then we just plot. So here's G double prime right there. H double prime should be right here. And then S double prime . 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Oops, sorry, I didn't connect, but there it is. Okay. Questions on this? All right, your homework for tonight is a half sheet. You only have 2 problems. Okay, use your foldables if you got them. If not, you're going to have to use Google to find these rules. I expect, first off, everything's plotted for the first one. I expect the intermediate image in one color and the final image in another color. So you're going to need 2 colors. All right. If you need to borrow any, they're up at the front of the room. I also expect you to put prime, double prime to label things appropriately. Okay. Questions on this? And since you got about half the period, I want it done before you leave. All right. You're just going to turn it straight into me and then you don't have to worry about it. If you need to borrow any colored pencils, they're at the front of the room. Just remember they don't erase very well. Maybe do it in pencil and then write over it. To here. To here. Hi. Good morning. I need this by the end of the period. Whitney saw me. I was nice at first. It's good for the please. Yeah. It's 2 problems. This way you don't have to worry about it. If that's happening today. I'm not gonna lie to you, I'm not 100% sure. I'm shocked that they're having off campus right now. They are? Yeah, they are doing off. CJ was still doing off campus too. Oh, it can stop for a minute? Maybe. Maybe we're seeing the end of this. But I don't think so. It's still pretty cloudy. Oh, you know what? As soon as Devin comes back. Oh, so guys, just a reminder, does everybody know, just in case we have an e-learning day, does everybody remember where to go for the Google Classroom, the Google Meet? I think I still need to activate it. All right, so, You will if it's an e-learning day, yeah. We will. You'll still be present, just at home. I think so. I'll post the schedule if it happens. Here, I'll show you where to find it because I gotta get it activated. So if you guys go here, oops, I don't know why that's there. If you guys go to just the stream, you guys see this Meet link. I'm going to generate it right now. Save. You would literally just click here and that's it. You're in class. Okay. Attendance is taken. So just make sure that you have everything. Make sure you're there. Okay. The e-learning schedule though. What is this? Oh, that's preschool. Hold on. Okay. High school. It's the following. So early bird is still at 6:05. Period 1 is still 7:05. Period 2 starts at 7:44. Period 3 starts at 8:20. Period 4 starts at 8:56. Period 5 starts at 9:32. Period 6 starts at 10:08. 7th is at 10:44. Your lunch happens at 11:15 to 11:45. And then you have work time from 11:45 to 12:35.
So that's tomorrow.
If that happens, it'll be tomorrow. Yep. Lunch study hall would be a free period. It's pretty much a half day. But this, well, it's a little longer than a half day. But this would prevent us from making it up at the end of the year. Okay? So the information will be there for you guys on the video so that you have it. Those of you watching at home, have a great day.